Basically pointers का the main use of pointer is accessing array elements, right? And passing argument to the function when function needs to modify the original argument, and passing arrays and string to function, and obtaining memory from the system, and creating data structures such as linked list, etc. Linked list or node-based application, node-based structures. Fine. So this is the use of pointers. Next step. चलते हैं इधर. So let's create very minimal thing like integer, say x is equal to say 10. And and I want to see what is the address of x, right? So what I have to use here, cout, and if I write here ampersand of x, it will display me the address of x. Address of x. It will display me the address of x, and I want to see the value of x. I will write cout /n value of x. For that I will write here ampersand of x, and on this address I want to see the value of x. So I'll put a star here. So it will show me the value of x.
So would that show you the value of the address or the value of x?
Ampersand of x gives me address.
The asterisk of the ampersand of x.
Yeah. Asterisk of ampersand of x will show me the value, because asterisk is a reference operator. Asterisk is a
Reference operator.
reference operator. It always referred to an address. Right? So let me click this and see what results comes out. So you can see it has given me the address. Right? So address of x is 0x6DFEEC. So this address it has shown me in hexadecimal format, and the value at this address is 10. Right? So let's copy this out. Let's try to understand this. So here x is your variable.
Okay.
And it contains a address 0x6DFEEC, and it contains a value 10. So here this ampersand is basically address of operator.
Okay.
Here this is star is basically the reference operator. Because why it is called dereference? Because it uses why dereference? Uses why dereference? Because it uses the address and refer to that memory location at memory location. Fine. So that is why this is called dereference operator, right? So address of operator is ampersand and star is dereference operator. And why it is
Okay.
called dereference operator? Because it uses the address and refer to that memory location data.
Okay.
Understood? So this is the basic conception regarding pointer. Now we go it in bit depth also. So
Okay.
next thing is how to define a pointer. Fine. So to define a pointer, what you need to do here, okay, you need to write here. Say for example, I want to define one integer pointer. So I've written here star p. So this is integer pointer, right? Integer pointer. And this integer pointer refers only integer integer pointer holds the address of only integer types, right? It can
Okay.
hold it can hold the address of only integer types. So what are integer types we have? We have uh, we have short, we have long,
Long,
and we have long.
long.
Yeah, long is also another data
Okay. And
type.
byte.
No, byte is not there.
Oh,
And,
okay.
and we have int, right?
Yeah.
So all these data types addresses we can hold in this pointer, right? If we define float pointer, it can hold the data types of double and float both, right? And the floating point type. If we define the float pointer, say we have defined here a float pointer, float star, say fp. So this pointer can hold. This is a floating point pointer. This one, floating pointer, which holds the address of only floating points. Like float and double, like float and double. And you can define double pointer also by using double type. But it can float can hold both float and double types, right? Acha. The next thing about what is the size of a pointer variable, right? Can you guess
Okay.
what will be the size of a pointer variable?
It will be the size of the data type.
No, the size of a pointer variable is 4 bytes. bytes, right?
Is it
Or
4 bytes every time, like for all
yeah,
the?
every pointer type, even if you can declare a character type also, it will be holding 4 bytes of memory.
Okay.
Or it depends, or it depends upon int type int type of the compiler you are using. Int type of the compiler compiler you are using. So in our compiler, the data type, the size of int type is 4 bytes. So size of our pointer is always 4 bytes.
Okay.
That means it can point to almost billions of memory location.
Okay.
Right. So we don't have to worry. It can We can use 16 GB memory location in 4 bytes. Fine. In higher type of server computer, we can the int type is 16 bytes or 32 bytes. So in that case, it can point to many other parts of the memory. Fine.
Okay.
So this pointer variable basically used to hold the address, nothing else. Okay.
Hmm.
So size of the pointer variable is 4 bytes, and whatever we are studying currently here, it will contain only 4 bytes. Right.
So is the
Now,
syntax the same for C?
yeah, C and C++ syntax is same. No issues
Okay.
with the syntax. The concept is also same.
Okay.
Right. Okay. So, now we try to assign this FP, writing FP equal to 10. Sorry, FP equal to X. So FP is a floating point pointer, and I'm trying to store X, which is integer type. So let's see how it works, right? So I try to store and it is giving me an error. So let's see what error it's giving. It's giving here invalid conversion from int to float. So I cannot store the integer data to a floating point pointer, right? I cannot
Okay.
store the
So
address of integer data in a floating point pointer. Understood?
okay. Hmm.
So what, and evenly if I store it like this, right, there will be another problem. If I use p and I am writing equal to x, and now you see there is a problem. Fine. So it's
Okay.
giving me invalid conversion from int to int, right? Int star. So what I have to do, okay, I have to store the address because pointer variable cannot hold the data,
Okay, that makes
right?
sense.
Pointer variable cannot hold the data. Pointer variable will hold the address of that data variable, address of that variable, right? So what I have
Okay.
to, I have to specify the address of operator here, right? Now
Okay.
you see the difference, right? So it has stored the address and it's giving me the answer, right? So
Okay.
if I print the pointer variable, all right? If I take here, see out content of pointers. So the content of the pointer is the address that way.
Okay.
Understood? And the address of X is this
Okay.
0x60FE8. Fine. Understood.
Right. Yeah.
So pointer variable can hold the address of another variable. Fine.
Okay.
So if you have a floating point, now if you want to print the content through pointer, how to do that? So for that you write here cout, and if you write here /n value value pointed by so if you write here star c, then what it will do? It will print the value.
Okay.
Right? Execute this. Now we can see value pointed by the pointer is 10. Right? So address of x is this, and the value of x is 10. So 10 is the content. Fine.
Okay.
So now, if you want to see the address of the pointer, what pointer, in which area the pointer is residing. So now you can print like this, cout address of pointer. Now you run this. Now you can see the address of the pointer. So address of pointer is 0x6DFEE8, right?
Yes.
So address of the pointer is this, and pointer is holding. This is the content of the pointer 0x6DFEEC, and this is the value pointed by the pointer, and this is the address of the pointer, right?
Mm-hmm.
So now if you want to print the whole this stuff in C language, what you have to do? So in C language, you have to use something like printf, right? And then you can write here, and then you write here /n content of pointer. And then here you have to write percentage of d, okay, and then write comma, and then put here p,
The pointer P.
right? The next thing is let's copy this out. Then you have to write printf control v, and here you write percentage of d, right? Because it's pointing to an integer variable. That is why I'm writing percentage d. If it is pointing to floating point variable, then I have to write percentage of f.
F.
Right. So this will be the thing. Next we put here semicolon. Fine. Then if you want to print the address of the pointer, same thing we have to do. So address of the pointer is always in hexadecimal format. So you can use percentage d.
Okay.
Percentage d, and then we need to remove this, and then put percentage p, and Then, so this much will be fine. I think you can understand the C language syntax. C language, yes, syntax.
Yeah.
So address will be printed in hexadecimal format. So instead of D, we use hex, right? So this is a C language syntax, and this is C++ language. C language syntax is supported by C++, but C++ syntax is not supported by C language at all.
Okay.
So I'm writing this program in C++, so it will support both.
Okay.
When you run this, it's giving me an error. Printf was not declared in this code. Okay. So to include printf, you have to write here hash include std io dot h. Fine, and then run this.
Okay. Content of the, why does it say the why is the content different?
Because instead of x, I have used d. Now you see.
Okay. Okay. And what is the 0x at the beginning in the C1, but it's not there in the C plus? It's not
In
there in
C,
the C, but it's there in the C plus plus.
yeah, yeah, because I have not used the, you know, because I know that in C language, I know that that value is in hexadecimal, right? In C language, I priorly know that the value is in hexadecimal,
Okay.
right? So I've given X, okay? And in C++, I'm not sure about what kind of value it will print. So with the, by printing 0x, C++ making sure that, okay, we are knowing that the value is in hexadecimal format.
Okay.
That number is in hexadecimal format.
Mm-hmm.
Understood?
Okay.
And in C language, we already know that number is going to be printed it in hexadecimal format. So we have provided that X, right? And if
Oh,
we don't provide X, instead of X, we provide D, it will be converted into integer. This hexadecimal converted into decimal and gets printed automatically.
okay.
Understood? So this is the basic conception regarding pointers. Fine. So let's move ahead. So this is what they talk about addresses and the pointers. Fine. Address of operator. If you study the same topic from your book now, it's given in very short. But if you study from this book, you will get a proper idea, yeah, how it works and right.
Okay.
So a pointer must have a value, right? You can declare a pointer to. There is a very interesting concept called void pointer. So you can, if you don't know the this pointer is going to point to which kind of data, then you can use a void
Void point.
pointer, and you can
Okay.
assign any kind of a pointer to that pointer, right? Because
Okay.
if you are assigning a float type of a variable to an integer pointer, then it will give you an error. But if you define a void pointer and you assign the float variable, it will be assigned, right? You can see here, int it's a integer pointer, this is a float pointer, and this one is a void pointer. Fine, and
Yeah.
these are integer variables, and they're assigning the addresses over here. So in void pointer, you can assign any type of variable pointer. So that is another good feature of void in C++.
Okay.
Fine. So let's give a try in our program. Let's define a void pointer because we have both the type of pointers here. So let's define a void pointer. And let's see. Let's declare a variable here, float. Float pi is equal to 3.14. Then what we can do here? We can declare void pointer, void star p int. So we can use this. Pointer. So we can make point equal to ampersand of ampersand of x, right? And then we can printf the address. We can see what it is printing. So we know the data is integer, so we put here this, and then we write here star point. Okay, and let's see how it is working. Void is not a pointer to type.
So because it is void, so we need to typecast it, right?
Yeah, we need to typecast it. Mm.
I think you should put the asterisk inside the bracket. Like before the point.
Correct. The point is not a pointer to object. So it's not a pointer to object. That means access point is having one address. Oh, let's use the book. You can assign the address of int variable to, but you can't assign the address of this. Anytime you need kind of a pointer to another, you can use reinterpret underscore cast for the lines. Sure. Okay. It's not printing. तो दिया हुआ नहीं है. चलिए काम करता हूँ मैं इसको इंटीजर पॉइंटर में चेंज कर देता हूँ. Now we try to content of the pointer, data pointed by the pointer. अरे उसका एड्रेस दे दिया. Now content of the void pointer दे दिया 6DFEE4, right? And data pointed by the void pointer is 10. Fine.
Awesome.
So यहाँ पे हम लोगों ने क्या किया? What we have done कि we have converted the point variable to a integer pointer first, and then we are dereferencing it, right? So ये वाला part copy कर लेता हूँ. So void. So this is void pointer. So it can hold. Sorry. It can hold. It can hold the address of any variable or object, right? So that is proved over here. We have stored here pointer variable variable is holding int variable address. Here void pointer variable holding int variable address. Fine. And to print and to access data with void pointer we need to convert the void pointer, convert our typecast. We need to typecast. Typecast the void pointer into our required data type pointer, and then use dereference operator, operator to access the data. Fine. तो ऐसे वो access कर सकते हैं. So regarding a pointer, your idea, I think so, basic idea is clear. No?
Yes, it is.
Okay. The next thing is pointer and arrays. So
Okay.
So there is a very good relationship between pointer and arrays, right? So the name of the array, let's use this example. And arrays. So here, when you define an array, right? So here they are defining one array called int arr ay. So this name of the array, the name of an array is a constant pointer, is a constant pointer of the given data type, of the given data type. It holds it holds the address of first element and the compiler uses the compiler uses the formula internally to access all the elements. elements. Fine. So in this case, int array is a pointer.
Okay.
Int array is a pointer, right? So int array is basically a pointer. And say for example, there are uh, values like 31, 54. Let me draw it like this. 31, 54, 77, 52, 93. So 31, 54, 77, 52. Right. So int array int array is holding the address of first element. So this element address, say for example 100, or say make it 1000. This address is 1000.
Okay.
So 1000 is held by this pointer. 1000 is held by this pointer. And this pointer has its own address, like say 5000. Okay. So 1000 means it's pointing to the first element. Right. The second address will be 1004. The third address will be 1008. The next address will be 1012. The next address will be 1016. Right.
Okay.
So what is happening here when you are writing int array of j is 0, right? So what is happening here? The the formula is here base address right plus plus size of data type multiply by shift value, right? So in the first case, the value of j is 0. So here j is shift value.
So this is basically like the address calculation that we did in class 12, right?
Uh, Class 12, right? Right. It's going like that only. So the base address is 1000, you can imagine, and the size of the data type is 4 here, and the shift value is 0, as the value of j is 0. So result is 1000, right? So it will access the first element. To access the second element, it will be using 1000 plus 4 into 1, which is 1004. So in this way, internally, one by one, you can access the element, right? So this is the relationship between an array and a pointer. And this value is always fixed. This value is always
Always fixed.
because it's a constant point. So we cannot change the constant values. Understood?
Mm-hmm.
So, so this is what it is done internally, and right now they are doing the same thing using pointers also. So here they are using, in this case, they are using pointers. Fine.
Okay.
Here in this case, they are using pointers. So, so here they are using pointers. Now you can see it here. Okay. Okay, they are using the, this is the address, this is the This variable is representing address, or you can say base address, right? And plus j means ki it is doing this part, size of data type multiplied by shift value. This
Okay.
plus j, this plus j means ke size of data type, size of data
Data
type
type plus shift value.
into shift value, into shift shift value,
Okay.
into shift value. This is what is happening over here. So it is generating, this is generating one address, this is generating one address, right? This is generating one
Yes.
address, and on that address I need the value. So I have to use the dereference operator. Understood?
Yes.
Fine. So this is the basic idea regarding array and the pointers, the relationship between arrays and pointers. Fine.
Okay.
This is what they have explained here. Just go through it. So here, that is what they are talking about here. Pointer constants and pointer variables, right? So suppose instead of j to int array, so you can define a pointer variable also, and you can increment the pointer variable. Fine, doing the same task. Okay, I'll show you one program here. So you can see here, here they instead of using the array pointer, the constant pointer, what they are doing, they are assigning the data, assigning the address to a pointer, and then they are incrementing the address, right?
Okay.
Every time. So when you increment the address, automatically that calculation will happen and the address is updated, right? And you can print the data on that address. Fine, that is what is happening over here. So here what is happening? Okay, here, so here what is happening? Okay, they are assigning the array. Oh, didn't cooperate. So now you can see here what they're doing. They are assigning here, assigning assigning the array or the constant pointer, or the constant pointer to a normal pointer, to a normal pointer, right? And now ptr int is a normal pointer. Ptr int is a normal pointer, which is not a constant. So we can increment the address of this pointer, right? So what they are doing here, they are using the, here it is a postfix operation. They are using the postfix operation. That means it will use the current address, print the data, and then the address of the point ptr int will be updated, right? So ptr int plus plus, it means the base address, it means the base address plus data type, size of data type, size of data type multiply by shift value, multiply by shift. Fine. So this is happening internally here every time. So if wait, I messed out a trick. This is not the case. This is not the case here. Here what is happening here? Here there's one address only. Fine. So the address, say the base address of the array is, this is your array, right? And the base address of arrays is 1000, right? So this 1000 is assigned to ptr int, right? So ptr int is containing 1000. Fine. Then what will happen कि when you apply this postfix operator, then ptr int will be updated to 1000. It will be updated to 1004, right? Then again, if ptr int is applied, then 1004 will be updated to 1008. Then again, when you apply ptr int plus plus, it will be updated to 1012. Fine. So in this way, it is updating the address and printing the data on that address. Fine.
Okay.
So you can add the pointer addresses, right? Or you can subtract the pointer addresses so that you can move backward also. Fine. By using the addresses. So this is how a pointer works. So basic idea. So if we do this much today.
Okay, sir.
Okay. और स्वेत तुम मेरा अपडेट किया वेबसाइट?
नहीं सर, एग्जाम्स था और नेक्स्ट वीक भी रहेगा, बट मैं वीकेंड में कर दूंगा.
अच्छा ठीक है फिर. और तुमने होम पेज बनाया था स्वेत?
सर होम पेज बाकी है बस, बाकी
अच्छा तुम बोला था
सब
होम
डाल
पेज ही
दिया.
बना रहा है. अच्छा
हाँ
बाकी
वही
सब डाल
होम,
दिया.
हाँ वही.
ठीक है फिर. ठीक है तुम बनाओ आराम से, कोई दिक्कत नहीं है. एक्चुअली हम भी बहुत बिजी जा रहे हैं, पता नहीं यार इतना काम आ रहा है ना. और फिर
ओके.
हो नहीं पा रहा है. हम तो आज सुबह 5 बजे सोए हैं.
अच्छा.
बुरा हालत है. चलो फिर सो आज बस इतना ही रखते हैं. मेरे को थोड़ा निकलना भी है, सॉल्ट लेक पढ़ाने जाना है.
ठीक है सर.
ठीक है चलो फिर बाय.
ओके सर, बाय.